Alright, so I'm going to go over Firestarter 11 for geometry. This is like some basic algebra stuff. So basically, this post-test study starts when we first started class. We started going over simple algebra stuff. So when it says evaluate, that basically means we're going to plug something in. So you're going to use plug and chug. So you're going to, wherever you see an A, you're going to put a 2. So right there, I'm going to put a 2. Wherever I see a B, I'm going to put a -3. Wherever I see a C, I'm going to put a 5. So I'm going to rewrite number 1. Now, I'm going to rewrite the top. 3 instead of B, I'm going to put parentheses -3 over, because that's a fraction bar. 5 instead of A, I'm going to put 2. Instead of C, I'm going to put 5. Now, I'm going to tell you guys this, and a lot of us aren't going to listen, but it is very important that you do the top and bottom separate. If you most people, when they try to plug it all into their calculator at once, they make a mistake, and they make a calculator mistake, because the calculator, because technically a fraction bar implies an extra set of parentheses around the top and the bottom. That's not something you talk about in math about. So my easiest way to around that is to just do the top by itself, then do the bottom by itself. So I'm going to do the top all by itself. I'm going to get -9. I'm going to do the bottom all by itself. 5 times 2 is 10. 10 plus 5 is 15. So -9 over 15. You could write it as a decimal. I'm not going to. I'm actually going to divide both the top and the bottom by 3. I'm going to get -3/5. Best answer right there. All right. Number 2. These bars right here, those mean absolute value. Alright, that's important because you got to understand what that means. And basically, it also means that it's basically parentheses in there as well. So I know D is -6, so I'm going to put -6 right in there for D. So I'm going to put 24 plus, in absolute value, -6 minus 4. Now, like I said, the absolute value bar is right here. That means absolute value. Absolute value is you do inside, and if there's a negative, you just make the negative away. So this becomes -10 inside the absolute value, which turns into just +10. So I have 24 plus the absolute value of -10 is +10. So I get 24 plus 10 equals 34. That's it. All right. 3. Now we're using penmanship backwards. So these are solved problems now. Now remember, whenever you're solving, you have to have all the x's on one side first. Because remember, this is going to be for one variable. So that means that you need to make sure all the x's are on the same side. So the first thing I'm doing, number 3, is I'm going to put all the x's over. So I'm going to minus 3x from both sides. Remember, whatever you do to one side, you have to do to the other. I put all the x's on one side. I always move the smaller one. Not that it really matters, but I like to move the smaller one, so those cancel. I end up with 4x minus 21 equals -33. Now, I'm going to use my primitives backwards, and I get rid of subtraction first. So to get rid of the subtraction, I'm going to add 21 to both sides, because you get rid of subtraction with addition. So I get 4x because the -21 and +21 cancel. Remember, see how there is 21 on both sides? That means I did balance it correctly. I get 4x equals -12. Now I have multiplication. So to get rid of multiplication, I divide. So I divide both sides by 4. So that means I end up with x equals -3. Now you can't always check your work, so you could plug -3 in there and there into the original problem to check your work. So 7 times -3 is -21, minus 21 is -42. It's supposed to be equal to 3 times -3 minus 33. So I get 3 times -3 is -9, minus 33 is -42. It's a true statement, so it works. So that's it for 3. 4, the first thing I'm going to do, Right, so once again, it's PEMDAS backwards. All the x's are on one side, so I don't have to worry about that right now. There's subtraction, but that subtraction is really inside the parentheses, so I cannot get rid of the minus 2 first. There's no addition, there's no division, there's multiplication. The most common mistake I'm going to see is somebody's going to try to distribute that negative 2. Somebody's going to try to do this. Don't do that. That is wrong. Right? You do not get rid of multiplication by multiplying. You get rid of multiplication by division. So I divide both sides by negative 2. That cancels those out and actually makes my problem much easier. Now you could distribute and eventually, with this problem, you could actually distribute if you really wanted to and then get the right answer, but I'm not doing it that way. And in the long run of math, that's not the best way to do it. So I have x minus 2 equals, I forgot a negative sign. Oh no, it's a positive. Negative over negative is positive, so it should be positive 10. Now, alright, the parentheses are gone, so now I have subtraction. So how do I get rid of subtraction? By addition. So then I end up with x equals 12. And once again, I can check my answer. Negative 2 times 12 minus 2. Does that equal 20? Well, 12 minus 2 is 10, so I get negative 2 times 10. That does equal negative 20. That's it.